everyone. Welcome again to my channel where you can learn a lot of things in mathematics. It's all about math, physics, science, in short, educational channel. Para mutigi sa Discovery Channel, joke lang. Okay, so welcome everyone to my channel once again. Ang channel na walang halong chemical. Lahat ay organiko lamang. Walang halong edit. Lahat ay puro. Okay, so please do not forget to subscribe, like, share, and comment if you have some requests or concerns or something like questions about the videos that I will be posting or uploading or uploading in YouTube or in my channel. But before anything else, I would like to flex the sections that I forgot to shout out last time. Hello, section Mirasol, Sakura, Daffodil, Waling Waling, hello. Sampaguita, hello. Alameda, Rosal, Sunflower, Carnation, and Zinnia. Hello everyone, how's your day? I hope you're doing good. Welcome back to Math is Fun channel. Dagana pag pangalan sa akong channel, no? Sige lang, laban lang, at least pangalan. Okay, so another thing also, flex ko lang yung mga kasama, yung mga kaibigan kong matematiko, Charmas at saka matematika, mura jud matematiko, mekaniko ni Monico, ang makina ng minika ni Monica. Okay, so flex ko lang si Ma'am Emmy sa garden, Ma'am Joanne, Ma'am Gladys, Ma'am Dom, Ma'am Doms, Sir Dom, sorry, Sir Ariel, Sir Jason, Sir Miapes, Ma'am Dagbak, Ma'am Maglibog Baktin Dagpin, Dagpin, Ma'am Dagpin, Ma'am Mata, Ma'am Dorado, and also Ma'am Curato, ang coordinator DI sa grade 7 curriculum sa Davao City National High School. Hello, ma'am! So, welcome to my channel, ma'am. Na-mention na dyan ka sa kong channel. Okay, so, this time, dagan pag introduction no kayo sa kuang video discussion. So, this time, we're going right away, or we go right away to our main purpose of this video, which is about Chan-charaneng! Ay, Chaka. Chaka ang share screen. So, let's just wait. Now, let's be again i-enjoy lang natin ang mga lessons this afternoon. Not this afternoon, this session. Maybe it's evening. So now, our topic is something to do with the drawing, not in the calculator. Look at the drawing there at the center. So the figure. So our topic will be related to okay, so our next topic this session or in this video discussion is all about universal sets and subsets. So I hope you can follow and you have already idea about this one. So now let's define first what is a universal set. What's the difference between universal set and subset? And what's the relationship? So there are things that you will ask about this topic. So let's start with the definition of a universal set. So what's the definition? It's there, you can read. So the universal set is the set of all things pertinent to a given discussion or the topic or what is being talked about or discussed. That refers to the universal set. Again, it is the set of all things pertinent to a given discussion and is designated by the symbol U. So all things related to a given discussion or pertinent to a given discussion, we call it universal set. And it is denoted by the symbol U, capital U, as you can see on the screen. Okay. So now, let's have an example. The universal set U are sets of all students at ATC. Some subsets are all high school students. Others can be freshman students. Others can be sophomore students. So, in short, set A, B, and C, they are all under the universal set. Okay? So, that's the difference of subsets and universal set. So, a universal set, again, it is the set of all things pertinent to a given discussion. So all things, all the elements, even sets, they're all inside in a universal set. It is just like a concept of the world where we, people or human creatures, and also non-living and living things, we are all inside the universe or inside, example, Earth is the universal set. We are inside in the planet Earth. So meaning to say the planet Earth can be considered as universal set. So another concept also for universal set. Try to imagine the planets in the solar system. They are part of the universe. Therefore, or galaxy. So therefore, we can say that the galaxy is the universal set. So in short, everything, all elements, all sets are inside in a universal set. That's according to the set theory. I want you to remember that one. So to grasp rather the concept of universal set, let's set an example. Again, as I have said, universal set is a set where the elements and other sets are inside of it. So meaning to say, for example, we have the universal set is a deck of ordinary playing cards. How does it possible? We all know that in a card, it consists of how many playing cards? From ace to king, including joker. Okay, so a deck of ordinary playing cards is considered as a universal set. So each card is an element in the universal set. Ace card is a is an element of a universal set, which is the or a deck of ordinary playing cards. Can you follow? So some subsets are, we have the space cards, numbered cards, suits, poker hands, so on and so forth, including the club cards, face cards, I mentioned already. So Joker, Joker is not part, right? Because we don't use Joker in a playing cards. It's just like pakapin. So now listen, everyone. So that's a simple illustration of a universal set. Okay, let's proceed. Another thing, so that it will be easier for us to visualize what is a universal set, I presented there a Venn diagram. Shows the universal set. In a Venn diagram, the rectangle represents the universal set. Again, the rectangle, this one. So this one represents the universal set. And it is represented by a symbol. Again, do not forget with the symbol of a universal set, which is U. So U, capital U is this one. This what's happening to my drawing? So U is letter U is considered, or that is the symbol that represents a universal set. So that is a universal set, and it is required for all Venn diagrams. So all Venn diagrams in our next topics or videos will be, it is required, or it must have a universal set, or it is or a universal set is required for all Venn diagrams, because everything, all elements, members, and sets are part or inside in a universal set. That's according to set theory once again. Sorry. So, what is now a subset? So if all elements or members of a given set or even all sets are inside in a universal set, what is a subset? How do you define a subset? So a subset, as you can see there, a subset is what? We consider a subset as, in this illustration, if A, sorry, if A is a subset of B, if every element of A is also contained in the set B. Again, I'll repeat, A or set A is a subset of B if every element of A is also contained in B. That's why it is written in this symbol. So this represents that A is a subset of B. Again, that will happen if B or every element of B is what? Is also contained in B. So this is how you illustrate a subset. See? There are elements of A that is also the elements or inside in B. So in short, A is a subset of B since there are elements of A which contains also in B. So in short, A is part of B. From the word itself, part, that refers to a subset. In short, A is part of B. Since A is a subset of B and every element of A is contained or also in B. That's why that's how we illustrate a subset. For example, for instance, the integers or the set of integers, as you can see on the screen. Why am I am so fast? So as you can see, class, or everybody or audience, in the example, we have the set of integers. The set of integers -3 until 3, so on and so forth, is a subset of the set of real numbers. So in a formal definition, we can say that a subset can be represented in this notation. A, please remember the um, symbol. Means that if X is an element of A, then X is an element of B. So that's how we define a subset. So again, the concept of a subset means there are elements of A that is also an element of B. In short, A is part of B, as you can see in the Venn diagram. So that's it. So example of a subset, the set A. So in set A, it consists of the elements 3, 5, and 7. So it's not a subset of B. Why? Why is it 3, 5, and 7 is not a subset of set B? Because 3 is an element of A, but it is not an element of B. Look at the element of B. The elements of B, rather. See, you cannot see 3 in the elements of B, or in set A, in set B, rather. So, meaning to say, set A is not an element of B. So it's not an element of B. I want you to be I want you to remember the what we call that. Remember always the symbol and also the concept of a subset so that you will not forget it. Sorry, um, I will just add the symbol because others. This is the symbol in the module. So again, subset is symbolized in the symbol based in our um, reference in the module, this one. So this is a symbol of a subset. I'll just add something. Okay? Do not forget, this is the symbol of subset. So there is something line below it or underscore below it. So meaning to say, if it's not a subset, then this is the symbol for not a subset. Okay? So I hope you can follow. So in short, class, another thing also that I want you to remember, the empty set is a subset of every set. Can you follow? The empty set is a subset of every set. What does it mean? Every element of the empty set is an element of every other set. That's the reason why the empty set or a null set is a subset of all sets. In short, all sets given, they have an element of a null set, which is nothing. Again, I'll repeat, an empty set is a subset of all sets. Empty set or a null set is a subset of every set. Again, because every element of the empty set is an element of every other set. I keep on repeating it so that you will not forget it. Okay? So shall we proceed? Do not forget the symbol, okay? The symbol there on the screen is wrong. So you have to remember the symbol for a subset, this one. Subset. This one, not a subset. So please do not forget. And another thing, a subset is a part of the set or a universal set or part of any set inside in a universal set. So another thing also that I want you to remember in this slide, an empty set is a subset of all set because every element or every element of every other set consists of a null set or an empty set. So, okay, are you all okay? So I hope you can still follow in spite of all of this online discussion. Okay, let's have an example. Fill in the blank with subset or not a subset to make a true statement. So sorry, excited pa. Letter A. Is letter A, sorry, is letter A, is A, B, C, or the elements, or is this, or do they, is this a subset of this set containing elements A, C, and D? What do you think? Later, I will answer. I'll show you the answer. For letter B, is 1, 2, 3, 4, or is this a subset of this set? Is 1, 2, 3, 4 a subset of this set 1, 2, 3, 4? Let's see. So now, let's check your answer if you have the same answer. Okay, who got the correct answer for letter A? So in short, letter A, ABC is not a subset of ACD. Why? Because there is an element of this that is not an element in the other or in the given set on the right side. Look at B, or this set does not contain B, and this set does not contain D. So in short, there is one element of this set that is not an element of the other set. That's why they are said to be not a subset. Claro, is that clear? So next, letter B. Why is it letter B is a subset, sir? It's pretty obvious. It consists at least one element, no? But in this case, all elements are also the elements of the other set. So meaning to say, they are, or this set is a subset of this set, rather. So in short, what's your conclusion? Another thing to take down note. Remember, a set is a subset of itself. Again, a set is a subset of itself. So do not forget that one. That is very important. A set is a subset of itself. A null set is a subset of all sets. That's it. Now, counting subsets. One method of counting subsets involves using a tree diagram. The figure below shows the use of a tree diagram to find the subsets of A and B. So A is an element of a subset. So B is an element of the subset. And 4 is a subset of what? Okay, let's have this. So example, we have yes or no. Yes or no. Of course, tree diagram. In every yes, there is yes or no again. And then in our no, there is, or it consists of yes and no. So in short, 4 subsets. We can just have it yes or no as A and B. Then we have it, yeah. So now, as you can see, the 4 subsets that we have A, B, A, B, and a null. Sorry for this. Let's just focus on this. The subsets of A, B consist of A, B, the set itself. Then it consists of a letter A, check. And also, it consists of an element B. You can read this one as element of B, subset B rather. Okay, another thing also, it consists of a null set. So that's why this one, there are 4 subsets all in this given set AB. Again, the subsets of AB are the subset A, B, A, subset A, subset B, and a null set. Be careful in readings, huh? Because you can read this one as a subset AB, subset A, subset B, and also, of course, the null set. If there is no braces, that means element. Example, A, we consider it as element. B, element. So when you put like that, that means it's either a set or a subset. So I have to make clear on that. Okay, that's how we count or counting subsets. Next is the number of subsets. How do we determine the number of subsets? The number of subsets of a set with n elements is 2 to the power of n. So the number of proper subsets of a set with n elements is 2 to the power of n minus 1. Okay, again, the formula to identify the number of subsets in a given set is 2 to the power of n, where n is the number of elements. Okay, so again, the number of subsets of a set with n elements is the number, or can be solved using the formula 2 to the power of n. That is the formula, or this formula will help us find the value or number of subsets in a given set where n is an element. And this one, 2 to the power of n minus 1, this is a formula to find the number of proper subsets in a given set. So I'm giving you right away the formula. So again, if you want to identify the number of subsets in a given set, then use this formula. This one, I'll check for a while. You can use this formula. And if you want to identify or determine the number of proper subsets in a given set, then you use this formula, 2 to the power of n minus 1. So I want you to remember that one. So how to use that formula? Let's have an example. We have a subset a while ago, A and subset containing the elements of A, and a set containing the elements of A and B. So we all know that the subsets of these are the subset, the set itself, B. We have subset A, or set A, set B, and the null set. And then we determine that the number of subsets in this given set is 4. So how do we use the formula? 2 to the power of n. So again, to find the number of a set, using this formula, sir, can I do this one, the manual thing? Yes, you can do the manual thing, the listing. However, what if you have a lot of elements, like 10 elements in a given set? So it will be like, it will take you long to get the number of subsets in a given set. So this formula is very helpful. Look at 2 to the power of n, wherein what is n? Number of elements. Just count the number of elements. 1, 2, A and B. So 2 squared, which is equal to 4. Oh, did we arrive with the same answer? Yes, we arrived in the same, with the same, or in the same answer rather. Wow, why with? In the same answer. Okay, now, how are we going to use the formula, or this formula, in finding the number of proper subsets? So to identify the number of subsets in this given set, A and B, we'll still use the formula 2 to the power of n, as you can see on the screen, minus 1. We all know that n is, or refers to the elements of a given set, which is 2. Minus 1, then you have it 2 squared is 4, minus 1, then we have it 3. Oh, it's not working for a while. So the answer is 3. Okay? So the number of subsets in the given set AB is 4, using the formula 2 to the power of n. On the other hand, to find the number of proper subsets in a given set, then the formula that we can use is 2 to the power of n minus 1. So do not forget the formula. So I want you to remember that one, because in your notebook or in other references, you cannot find the formula in finding the number of proper subsets in a given set. Okay? So that's how to find again the number of subsets. So example of subsets, as you can see, I gave you an example a while ago, but let's have another example. Find the number of subsets and the number of proper subsets of the set Mathy, M-A-T-H-Y. So there are how many elements? There are 5. Counting the letters, 1, 2, 3, 4, 5. So since there are 5 elements, the number of subsets using the formula 2 to the power of n, where n refers to the number of element. So we have it 2 to the power of 5, which is equal to 32. Why 32, sir? Why not 2? Why not 10? Again, 2 to the power of 5 means 2 times 2 times 2 times 2 times 2, not 2 times 5. This is wrong. Okay? So this is the correct. That's why the answer is 32. Next is the number of proper subsets. So how do we define, or what I mean is how do we find the proper subsets in the given set? M-A-T-H-Y. So same process, you will just subtract 1. The answer is 31. Okay, who got the correct answer? I hope everybody got the correct answer. Thank you so much for listening. So now, I mentioned proper subsets, but I did not discuss yet or define yet the proper subsets. At least it's advanced that you'll be able to know how to determine or find the number of proper subsets in a given set. Now, this time we're going to define and describe what is really a proper subset. So as you can see on the screen, it's the definition is there. We can say, or we consider a proper subsets as, or if a set A is a subset of a set B. In short, the first requirement to consider that the sets are, or it is a subset, or it is a proper subset rather, it must be a subset. In short, A or set A must be a subset of set B. That's the first condition of proper subsets. Again, a proper subsets, we have conditions to follow. The first condition is, we can state in this way. If a set A is a subset of a set B, in short, it's a subset. Next condition, it is not equal to B. Again, if a set A is a subset of a set B and is not equal to B, then we call A a proper subset of B. So remember the one that we used symbol a while ago, so that refers to a proper subset. So a proper subset must be defined as this. If a set A is a subset of a set B and is not equal to B, then we call A proper subset of B, and write this in a symbol as this. So the Venn diagram, as you can see rather, shown on the screen, the Venn diagram for a proper subset is shown below. In this case, if we have the universal sets 1, 2, 3, 4, 5, and set A consists of 1, 2, 3, 5, and set B consists of 1 and 3. So what have you observed? So this Venn diagram shows a proper subset. So in short, since A, we illustrate that A is a proper subset of B. Why? Because there is at least one element of A that is not in B. Correct? What is that element of A that is not in B? 5. Element 5 is not in set B. So meaning to say, we can say that A is a proper subset of B. Again, set A is a proper subset of B because there is at least one element in A that is not in B. Or there are elements of B that is not in what I mean, there is at least one element of A that is not in B. That's why we say in our definition that a set A is a subset of a set B and is not equal to B, because there is something like at least one element in A that is not in B. That's why A is a proper subset of B. I hope you can imagine or understand what I am trying to say. So now, again, let's have an examples about subsets and proper subsets. So let's see. If A is 1, 3, 5, as you can see in the Venn diagram, and B consists of elements 1, 2, 3, 4, 5, and set C consists of elements 2 and 8, then we can say that A or set A is a proper subset of B, or in this, or can be written in the symbol. Why? Because A is part of set B. That's why A is a subset of B. And then we can say that C is not a subset of B. Why? Sorry. C is not a proper subset. C is not a subset of B. Why? Because, why? What's the reason that C is not a subset of B? Because there are elements of C that is not, or C is not included in B. It must be, sorry, the wrong symbol. It must be like this. C is not a subset of B because there is at least one element of C that is not in B. Okay, there are elements of C that is not found in B. That's why C is not a subset of B. Okay, so I hope you can follow. So another example so that I will be able to master it. Example, we have a given set 1, 2, 3, 4. Its subsets, we have 1, 2, 3, 4. Of course, to name the subsets of the set A, we have it. Of course, we start with 3, 4. We name 3, 4 as B, consists of the elements 3 and 4. And set C consists of elements 1 and 4. The null set is a subset of itself, of the set, of every set rather, as I mentioned last time. 1 and 2, 2 and 3, then 1, 2, 3, and 4. And we forgot it here, the another subsets, the 1, 2, 3, 4. The subset or the set itself is a subset of itself. A set is a subset of itself, rather. Again, given this set, we have the subsets 1, 2, 3, 4, the set itself. Then the pairing of 3, 4, 1, 4, 1, 2, and 2, 3. And also considering the null set, since a null set is a set of a subset rather of every set. And also the elements or the subsets 1, 2, 3, and 4. The subsets 1, 2, 3, and 4. Okay? So its proper subsets are for 1, 2, 3, for the set 1, 2, 3, 4, we have 3, 4, 1, 4. Yes, 1, 4. We have 1, 2, the null, 2, 3, 1, 2, 3, and 4. So why is it that the set itself is not a proper subset? That's a good question. See, look at the proper subsets. There is no set itself. Again, we defined a proper subset a while ago that a proper subset is, yes, it's a subset. It's a subset. The second one is that must be, or if A is or consists of at least one element that is not in B, so that's why we call it a proper subset. So 3 and 4, there are elements like 1 and 2 that is not present in B. That's why 3 and 4 is part of a proper subset. 1, 4, in this given set, 1 and 4, there is no 2 and 3, at least one element that is not in other set. So D is a null set. Okay, it is considered as proper subsets because There are elements of A, 1, 2, 3, 4, which are 1, 2, 3, 4 that are not in the null set. That's why a null set is a proper subset. 1, 2, see 1, 2, 3, 4 is not in 1, 2 set or subset rather. 2, 3, 2, 3 is 2, 3 is it's in set A, but there is 1 and 4 that is not in the set 2, 3. Okay, so 1, 2, 3, 4, so on and so forth. Going back to my question, why is it the set itself is not a proper subset? Because we cannot see there is no at least one element in A that is not in the set itself. Because set itself means it consists of all elements in the given set for the other set. That's why the set itself it's not a proper subset. Okay? So the set itself is not a proper subset of other set or a given set. So that's it. That's the concept. So before anything else, I would like to remind you about the different symbols for in a set theory or set notation. Again, I'll just add subset. Others, you know what? Other references, they use as this as a subset, but it's really a proper subset. We consider a proper subset as a subset. Remember, we cannot say that a proper subset is a proper subset or a set given is a proper subset if it's not a subset. The only thing that differs them in a proper subset, there is at least one element of the other set that is not in the other set. In a given set that is not in the other set. That's how we say it. The union will be tackled next in the next video. Intersection, the elements, not a subset, just add like this. Null or empty set, not an element. So I want you to remember this. Okay? Let's, I will, this is not part of the focus of this video, but I will also include this one for additional information. Power sets, when we say power sets, given the set S is equal to 0, 1, what are all the possible subsets of S? So remember how to get the subsets? There are, in this given set, 0 and 1. What are the subsets? We all know that there is a null set, 0, 1, and the set itself. So now, these are the subsets of the set S, 0, 1, containing the elements 0, 1. So the power set of S, written in this notation, take down note, is the set of all subsets of S. That is why a while ago, the set itself is not a proper subset because it is a superset. The question that we had a while ago is answered here in power sets. Again, the set itself is not considered as a proper subset. Why? Because the set itself is a power set. Yeah, it's the set of all the subsets of S. So that's a power set. All the subsets of a given set is called a power set. So in short, the power set denoted or represented in the symbols are null, 0, 1, and 0, 1. I hope you can follow. Okay? So we can now formally define a power set as the set of all subsets of a set A. Sorry, the dogs are barking. He wants to join with our discussion. So again, the set of all subsets of A denoted this one. This is the symbol for a power set. Is called power set of A. So as I have said a while ago in the example, a set A consists or containing A and B as our example, or elements A and B, then the power set is equal to the nulls, to the sets or subsets of all set A. We have the null, the A, B, and also the set itself, A, B. So these are the power sets. So if a set has n elements, then the cardinality of the power set is 2 to the power of n. Remember how we get the number of subsets in a given set? 2 to the power of n. We mentioned that one a while ago. That is also a formula in for you to get the number of power sets, or the, yeah, to get the power set. The formula that we can use is 2 to the power of n. So if you want to list them all, then you can list them all. Because according to the definition rather, power set rather is the set of all subsets of a given set. So the formula to get the power set of a given set is 2 to the power of n. If you want to list them, then you can use the Rooster method to list all the elements, or to list all the subsets rather, not the elements, to list all the subsets of a given set. See? We don't call them, okay, to write the power set. I want also to emphasize this one. Look at the power set. The subset, or the list of subsets in a given set, or all subsets of a given set. Look at, we have braces inside the set because we consider this one as the subsets. All subsets of a given set, not the elements. Okay? So I hope you'll be able to remember this one. This is very important, though something like confusing, but I believe that everything here is fine and okay. So I hope to see you soon in my next video. Thank you for listening. It took us long because we really have to um, discuss it clearly, and more, we have to really like be organized in the discussion of the universal set, subsets, and we included the proper subsets and also the superset, or we call it power set, or the other one. What I mean is including also the power set. So that's it. Thank you so much for listening. I hope you'll be able to enjoy it. If there is something like not clear to you, kindly just post it on the comment below. I'm going to correct it if there's something to need to be corrected. Okay, so thank you so much for listening. Do not forget to subscribe, share, and like and comment. See you in the next video. Adios. Thank you for listening.